I forgot to unmute myself. This is frustrating. Okay, listen. So, I figured out the problem. I finally figured out why this is happening. So, I was using my iPad because I thought if I use my iPad, it'd be easier for me to explain to you guys, right? Kaya Oli dari tadi itu sebenarnya pakai iPad gitu kan ya, right? And I think because I connected my iPad to the OBS, I think that's causing problems and causing bugs. I don't know why though. But I think that's the reason because right now I'm using Paint and everything is smooth sailing from here. So I think we'll be studying with Paint instead of an iPad instead. Yeah. Can you guys hear me? Kedengeran? This whole time, yes, I think this whole time is the iPad's fault. Kayaknya akhir-akhir ini, kenapa kita dari kemarin selalu lagging? Pasti karena iPad. I think it's always because of iPad. It's not because of my internet. It's not because of YouTube. It's because of my damn iPad. I don't know why. Gak ngerti mengapa gitu. Odrizer hates Wi-Fi. Anyways, finally, let me do my opening. Just one more time. Only opening bentar ya. Zamawa subakawai zombie idol. Crazy. Ali desu. Everybody, welcome to the stream. Selamat datang ke streamnya Ori no Haishin de Yokuso. After so long, we're finally streaming maths. ついに来たよ。数学の配信。はい、今日はね、linear algebra を勉強したいと思います。So today we'll be studying linear algebra. Hari ini kita akan belajar apa sih? Linear algebra. Betul. Let me spell it out for you guys and excuse the handwriting because I'm using a Paint. Yay, math! I've never done math before. What do you mean you've never done math before? Kevin, you're a game developer. You need maths, vectors, and if anything, matrices to make games. What do you mean? Not to mention, you're using linear algebra. What? Okay, so linear algebra. Ali, I'm hiding in the bathroom, skipping work, watching you. Let's go. Don't tell my boss, especially don't tell Mama Ina. No. Go to work. Go to work. If you have time to watch my stream, then you have time to work. Go. There's always the archive. You don't need to worry because we're not lagging anymore. Okay? Okay, kalau gitu. What bra? Algebra. The best kind of bra. The coolest bra ever. Yes. Okay, so let me explain to you guys what linear algebra is. Oli akan menjelaskan sedikit tentang apa itu linear algebra ya. Jadi algebra itu kita mulai dari algebra ya. We're going to start from algebra. So algebra is. 本当にいいの? ありがとう. Thank you so much for the really nice super chat, big super chat. Thank you. Yeah, I'm going to say it again. So basically, algebra is when you try to look for the value of a certain variable that you don't know yet. For example, okay? Let's say we have x plus y quadrat equals x quadrat plus 2xy plus y quadrat. So you don't really need to know the value of x or y to actually solve this equation, right? Kan tadi kita udah tahu algebra itu apa. Sekarang kita akan cari tahu apa itu linear. We already know what algebra is. So let's actually take a quick dive to linear. So basically, when we come across linear, basically, it has the word line right here. That means we're going to have a lot of relationships, a lot of interactions between one line and another. I want to give you guys an example because sometimes if people see like x's or y's, or if they see any variable in a certain equation, they'd be like, oh my gosh, this is linear algebra. No, it's different. So let's say 本当にいいの? ありがとう. Thank you so much for the big super chat again. Thank you. It means a lot. I'll try my best to teach. So anyways, let's say we have x plus y quadrat. I don't know what square, right? X plus y square. If we have x plus y square, this is algebra, but this is not linear. If you guys want a example of what a linear looks like, basically it looks something like this. Yeah. So it's not combined because if we have this, basically we're combining two numbers together. There's a relationship. There's a relationship between 2 and x and 2 with y. You know, if that makes sense. Okay? Kalian ingat matrix? Do you guys remember matrix? So basically, linear algebra is a knowledge where you utilize matrices. Remember matrix? Last time we had a math stream, we were also talking about matrix. Yeah. Matrix. So if you think that, oh, linear algebra and matrix, they're two different things. Not quite. I mean, they are different. But the thing is, matrix is matrix, while linear algebra, you use matrix to do a linear algebra. Get it? Ngerti? Okay, so basically, the whole thing about linear is that you're dealing with a line-like relationship, right? Think of it like this. If you guys are getting confused, linear algebra. If you guys are still confused to what linear algebra is, basically, this is when Matsuri Senpai and I meet and have a relationship. When two lines meet together, there are no curves at all. Easy peasy lemon squeezy. So, the whole thing about linear having a line-like relationship is already correct, but the relationships aren't between lines themselves, but rather between the variables. For example, let's say what example should I take? Light sticks and hoodies. Yeah, merchandises. Let's say 3 light sticks plus 2 hoodies is, let's say, I don't know, $100. Okay, let's say that 3 light sticks and 2 hoodies are $100. So if we have this, then how much is 2 light sticks plus 1 hoodie? This is usually where linear algebra takes in, you know? Dan di sini biasanya linear algebra masuk gitu. So those relationships are represented with lines because they are linear. It means that there's no changes in the gradient or the slope along it if we get technical. Okay? Thank you. Moving on. Kita lanjut. Oli kasih contoh lagi ya. So a very simple way of thinking linear algebra is, let's say again, we're going with the light sticks and hoodies. Let's say we have 4 light sticks and we have 2 hoodies. And they cost around, let's say, they cost $16. Yeah. And then we have 3 light sticks plus just 1 hoodie. And they cost $13. Now, if we want to write this down as matrix and vectors, basically, you gotta categorize them. You see these L's? The L stands for light stick. We can just put them here because they're 2 different things. And the value, or like the whole total, is going to be 16 and 13, right? We can just put them here. Okay? And then if we want to write down these, let's say this is the first time I'm buying merch. And this is the second time I'm buying merch. This is on the HoloFest second. Well, this is the HoloFest first. So we can write this down like this. 4, 2, and then on the second trip, 3 and 1. So this is a matrix. Well, these are vectors. Sombra, thank you. Does it make sense? Does it make sense? Did you have to use matrices, Ollie? Yeah, so... Oh, right, I haven't explained to you guys, huh? A lot of you guys might be thinking, yo, Ollie, why the heck do we need to learn linear algebra? Ollie, buat apa sih kita belajar linear algebra? Itu mereka nggak ada gunanya. So let me actually tell you guys the purpose. Let me motivate you guys a little bit before we get into the good stuff. Purpose of linear algebra. Okay, so jadi kalian tahu yang namanya machine learning nggak? Do you guys know what machine learning is? Jadi basically ya, mesin yang kita maksud ini komputer ya. The machine that wait, this is proposed, not purpose. Ollie, what the heck? Sorry, it's 10 p.m. Purpose. Wow. Okay. That's something. I'm very sorry about that. It's the purpose of linear algebra, not propose. One off. I'm sorry. No way I'm gonna use this in the future. You need this definitely. No, actually, listen. We actually use this a lot in daily lives. We do. Especially those who actually take computer science. Anyways, machine learning is like a type of artificial intelligence that allows a software application to become more accurate at predicting outcomes without being explicitly programmed to do so. So, machine learning algorithms use historical data as input to predict new output values. So, why is linear algebra important in machine learning? Finite? How do you pronounce it again? Element method. There's about like 7 billion, 7 billion, right? Or was it 7 trillion? Like a lot of people live in this planet. And we want to make sure, what is the... If we ever get to world hunger, let's say, okay? Or let's say we ever get to world extinction. What's the best method and how do we distribute food? How do we send help? And what's the most efficient way to do it? You can use linear algebra and your problems will be solved. It's pretty cool, basically. To put it simply, it's not very accurate. Yeah. Yeah, it's like, optimization. That's the word I'm looking for. And for math teachers, if I'm doing this wrong, I'm very sorry. I'm an English teacher, not really a math teacher. I'm just trying my best. Okay, so far, any questions before we move on? That was the definition of linear algebra. Yang barusan adalah definisi linear algebra. Apakah ada pertanyaan? Clear? Move on? No miss. Okay. Okay. Then, I'll tell you something. Let's review a little bit. So linear algebra, basically we're talking about line-like relationships, right? And what's a line in math? That's right, vectors. Vector. Going in both directions and magnitude! Oh yeah! Not that vector. But anyways, yes, a vector. Vector is basically something that moves around in space, whether it's physical or in computer science, data. How do I explain vector, actually? To be honest, anything can be a vector. Like, you guys know how vector is when we're talking about movements, right? You can use vector to actually put data in. You turn it into matrix, yeah. Let's take, for example, Ollie. Ollie is 102 centimeters tall. Ollie's age is 17. And Ollie's foot size is 38. This itself, this is data, right? And it instantly turned into a vector. While you look at that, as easy as pie. If for Ollie short, I'm not that short. I'm one of the tall girls in Hololive. Shut up. Okay. So vectors can be something where you move something physically, or when you it can also be a movement in data. I hope I got that clear. Now, next thing that I want to tell you guys about vector is that vector have two rules. Yeah, two rules. So vector has the addition rules. Addition. And it also has the multiplication. Multiplication by scalar. Jadi scalar. Ollie, what the heck is a multiplication by scalar? Don't worry. It's a big word, multiplication by scalar, but I promise you, it's the easiest thing that you guys will ever study. This is the easiest part about vector. Let's start with let's move vector real quick. Let's get rid of this. Get rid of that. Okay, now I'm going to start using the lines. Shapes. Okay, so let's make a little vector. Okay, kita bikin vector ya. Look at this little guy. We'll call him R. This little guy is a vector. Okay? And what do you know? This little vector has a friend. Has a friend right here. Oh, hello there. What's your name? Let's call you S. Yeah. And what do you know? S and R, they want to meet up with each other. So, what do? Well, you just pull a little line over here, and they'll meet up. They'll meet up in this nice place, right here. And this will be the time, and this will be the effort that they put to actually meet up with each other. We'll call this R plus S. Yeah. Some time. Okay? I wonder if I'm explaining this as easy as possible. Yeah, they meet at the center. Yeah. My OTP. Yeah. So this is basically addition, okay? And it doesn't matter how you draw it, basically. Let's say you want to draw S first, then you want to draw... Let's say you want to draw S first, and then you want to draw R. Oh, goodness. Yeah. Like this. This is basically the R. This is basically the additions of vector. Am I explaining this correctly? Addition. Wait, no. Oh, yeah. Wait, I'm drawing this wrong. Wait, I'm drawing this wrong. I was like, huh, this looks weird. I'm very sorry. Let's do that again. Let's do that again. Okay, so let's draw R first. Okay, we draw R. We draw R first. I'm sorry. Give me a break. I teach people grammar, okay? I teach people simple present tense. Give me a break. Let's say it's like this. And then they meet up over here. Yeah, there we go. There we go. That's what I wanted to do. Like that. Seperti ini. This is addition. Nice line art. Thank you. Actually, wait. The arrows are wrong. Wait. It's not supposed to go that way. It's supposed to go this way. Yeah, this is it. There we go. Ah. So this is the addition. Basically, how do I explain this? Basically, addition is when you go, is when you're taking a, it's when you meet in the middle of a journey. For example, you go here, and you know, if this was your starting point, then you can just pull a line over here. Thank you. And it'll be an addition of the vectors. Yeah. It's like walking along the path. And after you make a path, you go back to the starting line and you try to find the most effective way to go there. Okay. Cool. And then next we have a... Can we move on? Does everybody understand? Does everybody understand? Help, I can't understand. I'm sorry. Let's do this again. Let's try this again. The addition of vectors. Kita mulai lagi. Someone didn't understand. Thank you. I am responsible because I drew the lines wrong. So let's say that there is a vector. Right here. This vector is going up. This man is going on a walk. And then suddenly this man said, oh, I'm not supposed to go there. I'm supposed to go here. And so the man arrives at this point, while the man starts here. Now, if you want to add up the whole journey, then all you need to do is that you pull this over. Because R and S. No, because well, this is like the whole journey, right? So all you need to do is that you count the journey that the man already took. So it's basically a R plus S, if that makes sense. It's not a shortcut. It's just you just add them together. Jadi ini kayak cuma ditambah aja gitu loh. Pung, pung, you add them together. And it becomes R plus S. But this is how we draw the vector. Yeah. Is R plus S equals S plus R? Why, yes, it is. For example, let's make another line. Let's say we make another line here. So basically, this line is the same as this one, right? It just goes here. And let's say we make another line. We make another line and it goes like this. So like, they're the same length, basically. And this is called the associative personality. Yeah. So it doesn't matter if it's S plus R or if it's R plus S, or if you want to add 0 plus S plus R. To be honest, this doesn't make any sense. You don't need to put 0 in anything, but basically it's the same thing. Yeah. Well, to be honest, yeah, commutative. Wait, not associative, commutative. Commutative. And I'm drawing the arrows wrong again. No, but it's supposed to be like this. Sorry. Yeah, like this. From this side to this side. Because when you draw it the opposite side from this side to this side, then it becomes minus. I'm very sorry. Yeah. You guys are already doing good. Why do you guys keep asking me to teach you math? You guys are actually already correcting me. Okay, next is a multiplication by scalar. By a scalar. Alright, multiplication by scalar is actually a lot easier than addition. So let's say this is our starting point. Boop. And let's say we make a little vector. Hello, Mr. R. If we want to multiply R with 2, let's say we want to make a 2R. Then all we need to do is make 2 of these vectors. So it becomes this. And this is the length of 2R. Yeah. And let's say you want to make like, let me actually get rid of this. This is the length of 2R, 1, 2. You just multiply it and it becomes longer. Or let's say you want to multiply R with, I don't know, a quarter. You want to multiply R with a quarter? Then all you need to do is draw the line until here. Yeah, around this part. Get it? Let's say you want to multiply R with minus numbers. Like, let's say you want to multiply R with minus 3. Minus 3R. So what you want to do is that instead of going to the right, you go back. Because, you know, this is positive, right? Because it's positive, you're bouncing 2 places. But since this is negative, then that means you're going back 3 spaces with the vector. So we get 1, 2, 3. 1, 2, 3. And this is minus a 3 vector. Does it make sense? Easy, right? Oh, okay, that's an easy one. It's easy, right? Yeah. Okay, so, I've been talking about associative, a lot. And I got it wrong. It's not, the last thing we were talking about, it was like commutative, right? It's not associative. Now I'm going to teach you guys about associative. So let's say we have a line over here. Let's name these lines. We're going to name this line, let's see. We're going to name you Y. And let's name this line X. Okay? So let's say that we make another vector. Let's meet up with Mr. R. Hello, Mr. R. Yeah, here's Mr. R. And Mr. R is located at, let's say, 4, 2. You guys remember this, right? These are called coordinates. Remember coordinates? Like the ones with like the ones with lots of squares that you usually see. So like this is 1, this is 2, this is 3, this is 4. And the height is like 2. Like it's 4x and 2y, so it's like... Yeah, remember coordinates? Very easy, very easy. So we have Mr. R right here. Then let's say we wanna make Mr. S. Let's meet up with Mr. S. The same vector as before. And you know, because this is a coordinate, if we go to the left, that means it's going to be minus, right? So let's say that this is a minus 2 1. Because, you know, this is higher, this is lower. Let's just imagine this as minus 2 and 1. Minus 2 x and 1 y. Yeah. And you know, we're going to do some additions. S and R, they want to meet up with each other again. So we just pull some strings here and there. We're going to meet up at the middle. Yeah, we're going to meet up at the very, very middle. Over here. Is that visible? They want to meet up in the middle, right here. Right? So basically, we just pull another Mr. S. It's like the same thing. They're meeting up in the middle. And all we need to do is that we add them all together. So, additions. Basically, this is R plus S, right? R being 4, 2. And S being... Just a moment. And S being minus 2 and 1. So, this right here is going to be 2 and 3. Like the length of the X will be 2 and the height of the Y will be 3. Oh. Understandable? Yeah. And this is called associative. Doesn't matter if it's SR or RS. Cool. Now we're going to do something a little bit tricky. We're going to try and do multiplication by scalar. Let's make another Y. And then let's make another X. Kita bikin Y sama X ya. Okay, there we go. This is Y. This is X. Let's say that we have another Mr. R. Kita bilang aja kita ada Mr. R lagi ya. This is Mr. R. And let's say that Mr. R is let's see, 3 and 2. So like the length is 3 and it's like X is 3 and 2 is Y. Yeah. Let's say that we want to multiply this. We want to multiply the R. So what happens is that we draw another vector. We draw another Mr. R. How much will we have over here? Well, that's simple, because all you need to do is just multiply by 2, and then you'll get 6 and 4. Easy peasy, lemon squeezy. And let's say you wanna let's say you wanna multiply it by minus. It'll become minus R. And all you need to do is that you turn all of this into minus. It becomes minus 3 and minus 2. So we're going to go back from the original point. It becomes something like this. Understandable? Let's meet up again with Mr. S. We have Mr. S right here. And as you can see, Mr. S is going this way. Right? Mr. S is going this way. And Mr. S, let's say it has the... How much was Mr. S again? Was it in 2 and 1? Minus 2. And 1. Okay. This is Mr. S right here. Let's say that Mr. S has like an evil twin. An evil twin that doesn't, that really hates Mr. S. Like it'll be Mr. S minus. then what'll happen is that it'll go something like this. And S will also be minus. When it turns minus, all you need to do is multiply this with minus. So it becomes positive 2 minus 1. And let's say Mr. Positive R wants to meet up with the evil twin. Consult with the Mr. Minus S. All you need to do is draw a line like this. They'll meet up at this point, and all you need to do is add them together. So it becomes R plus minus S, which is 3-2 plus 2 minus 1. Right? This becomes 5, and this becomes just 1. So the length is 5. It goes here. So it's like a wait, right? So this is 3. We just pull it over here, and they'll meet up over here. You see? It's like the middle point. Yeah. 5 and 1. わかりましたか? I got it. Oh, it's easy. You're going to meet up over here. Yeah, the middle point. I gave you a 5 on rate, my professor. Wait, 5? 5 out of 100? Thank you. Oh god, what did I just see? The horror. What do you mean? This is simple. Now I'm going to tell you guys about the length of a vector and this magical thing called a dot project. Ne? So, let's meet up. Let's make another equation. So, this is going to be y. This is going to be x. Let's meet up again with Mr. R because Mr. R is our best boy. Mr. R right here in the house. Hello. This is Mr. R. Yes. So, let's say we want to project something. R is basically, okay? If we think about it, let's make a variable. The variable can be anything, actually. You can write it as x, or you can write it as literally anything. Let's write it as a. R is basically ax. Like, this is a variable right here. Plus by. Right? So basically, this is this. Right? Now from here, we actually want to know the length, and also where it's going. We want to know the dot project of Mr. R. So how do we actually get there, Ali Sensei? Well, that's easy. We just use Pythagoras. Kita pakai Pythagoras di sini. Yeah. So let's actually draw a line over here. Boop, boop, boop. Like a fading line. Boop, 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 boop. And from here, we got ourselves a little triangle. Wow, you look at that. And what do you do with the triangle? Well, first off, we know that this part of the triangle is R, right? And since the height is going to be y, then this is y. We can call this like the by, because this is going to be a variable, right? We don't know the length of it, or we can just write it as like length y. And then there's going to be ax, a as the variable, or we can always write it as length a. Now, how do you actually find the length of R. You just use simple Pythagoras. So, as we know from this picture right here, let me move this real quick. This will turn into a triangle like this, right? So this is A, this is B, and this is going to be the length of R. How do you find it? Well, through Pythagoras. So we're going to make a root A squared plus B squared. Easy peasy lemon squeezy. Why is that? Well, it's because R equals the vector A and B. Understood? Yeah. And so, well, now we know how to find the length of R. The next thing we want to know is how to define the dot product, which is one way of several of multiplying two vectors together. For example, let me make a new equation. Delete this. Maybe right here. Let's not make it too big. Trying my best here. This is going to be Y. This is going to be X. Okay, let's meet up with Mr. R. Again. Never get bored of Mr. R. Mr. R is our one and only savior. So this is Mr. R. Again, Mr. R is currently right over here. Let's say that this is a tree 2. And as we demonstrated before, basically, this is AX and BY, right? Or we can, or to make it easier, we can actually write it down as RX and RY. This is Mr. R's attributes. Now we're going to meet up with another friend, Mr. S, as per usual. So this is S. Ugly looking S. Ugh. What have you been drinking, Mr. S? Mr. S attribute, let's say it's a -1 and 2. And we write this down as SX and XY. Because the length of the X is -1 and it's 2 when it comes to the tallness. Right? Now, again, we're trying to find the dot product, right? So what we want to do is that we want to multiply the two vectors together. So what we do is that we get R and S together. And when we get R and S together, that means we're multiplying these two vectors, right? So this becomes RX times SX plus RY times SY. Okay. So then we'll have 3 times -1 plus 2 times 2. Becomes 1. Remember, this is R times by S. It can also be written as S times R. Doesn't really matter. Understood? Thank you. This is called the commutative. The commutative, right? Not associative. The commutative. Yeah, and the vector becomes it becomes -3 and 4. And this is the dot project. Commutative. Now this is commutative. Next thing I want to teach you guys is the distributive. let's say we have another friend. Let's meet up with a new friend. S and R, they're good friends, but they feel lonely if it's just the two of them, so they invite a new friend. Let's call T. Mr. T. Oh, Mr. T. Yeah, so if we wanna get the dot product from this one, we still need to multiply. And how we do that is first of all, since S and T, they're on the same, how do I say it, line, kind of. It basically becomes R plus S. No, it's not plus. R times S plus T. And when we get R times S plus T, we get this. Which is like ini cuma diperpanjang aja. Apa difaktorisasi? Bukan faktorisasi. Jumlahin. Iya. RT. Okay. And we've talked about how R equals to Rx and Ry, right? So basically, R can be like R1, R2, yada 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 yada, until R infinity to whatever number it is. And the same thing goes to S and T. This is S1, this is S2, yada yada yada. Onwards, and the same goes to T. T1, T2, yada yada yada, T infinity. Right? And from here, we can write it down as because we know that basically this is what the RSTs look like. If we're going to gimana ya? Gue bakal dijumlahin lagi jadi R1 dikali sama S1 ditambah R1 dikali sama T1 ditambah sama R2 dikali S2 ditambah R3 kok R3 tiba-tiba R2 dikali sama T2 dan seterusnya. It goes onwards. And we can just simplify it as R times S with R times T. Basically this. This is just me proving that this is this and this applies to this. If that makes sense. Yeah. This is the distributive sifat of vectors. Yeah. Now let's say we want to find the dot product using scalar. Like there's suddenly scalar in here. Like let's say S gets multiplied by A. Bilang aja ini tiba-tiba S ketemu sama scalar gitu. Ketemu sama scalar terus akhirnya dia kena multiplikasi. All you need to do to actually and let's say that T never existed. Kita ilangin T ya. Let's get rid of T. We got rid of T and suddenly S got an upgrade and it has a scalar now. This variable can be anything. It can be 2, 3, 4, 5, whatever number you want. So how do we count this? Well, we count it the same way we counted the past one with the T. So it's R. We just multiply R with AS. Understood? And when it becomes R multiplied by the scalar S, the AS, it becomes something like this. Basically, it doesn't matter because everything will get multiplied anyways. And we can write it down as, if you guys want to see the long run, it becomes something like Rx multiplied by ASX plus RY ASY equals A multiplied by Rx multiplied by times by SX plus RY times SY. So this is called the associative over scalar multiplication. Oh, Rainy! Ini stream bahasa apa lagi? Rainy, welcome! We're just talking about how to look for dot projectors and vectors by using the associative over the scalar multiplication. Hello, Rainy. Welcome to the stream. Everybody give it up for Rainy, my genmate from Hololive Indonesia Generation 2. She's a Monopoly master. It was her first time playing Monopoly today and she won. It's pretty easy, right? Yeah. I don't know, but it feels like they make algebra different. Well, you can blame algorithm for that. I think I get it. Good! Because next up, we're going to study about the cosine and dot products. Berikutnya kita akan belajar tentang cosinus dan dot product. Cosin dot product. Yeah. So let's make a little triangle, okay? Make a little triangle. We're going to name this side Mrs. A. We're going to name this side Mr. B. And then we'll get a C. Over here. Yeah. Actually, no. No, we don't make a triangle. We make vectors. That's what I wanted to say. I was like, wait, Ollie, what are you saying? Then we're meeting up with Mr. R and Mr. S again. There we go. I felt like something was wrong. So let's say this is Mr. S going over here. And then Mr. R over here. And then all we need to do is change them. We're going to merge them together, make them a fusion of a triangle. I wonder if this is clear enough. Maybe I'll use the pencil. There we go. Yeah. And this right here is going to be R minus S. So this is going to be our A side. This is going to be our B side. And this is going to be our C side, which is R minus S. And we're going to make a theta right here. This is going to be the angle. And do you guys remember the rule of cosine? Kalian ingat gak peraturan cosinus? Peraturan cosinus itu C square equals A square plus b squared minus 2ab angle with the theta. Yeah, here it is. This is the basic rule, right? Yeah, exactly! Wait, how did you know? Yeah, cosine is the adjacent and hypotenuse. Oh, that is correct! Huh? Yeah. So cosine is at how do you, we're going to do it like this. Adjacent and hypotenuse, which we're going to write as r, because I'm too lazy. Yeah. So let's say we want to look for the length of let's say that we want to look for the length of r minus s, which is actually just Mr. C right here. How do we look for the length of r minus s? Well, we just put the r and minus s into the cosinus rule, which is let's say that's c. Well, since we have c right here, so c is basically the length of r minus s squared. With a right here, the a will be the length of the r squared, and then it's going to be plus b is going to be the length of s. The length of s minus 2 length r times length of s with cos theta. You just put it into the equation. It's simple. And then, we just break it down. So what we get is that since this is squared, we can write this as length r minus s multiplied by length r minus s, which will be equal to basically r multiplied by r minus sr minus sr again because it's r with r, then r with minus s, so it becomes minus s, and then minus s with 1r, which is, well, again, minus sr, and then plus s. Wait, minus, yeah, plus s. Right? Wait, tunggu, bentar. I think I got it wrong. Wait. Okay, no, let's do that again. So this, if we write it down, it's basically the length of r minus s multiplied by the length of r minus s. And if we try to multiply this becomes r times r, which is this and this. And then r times minus s, which becomes minus sr. Then minus sr times by r, which is another sr basically, times by minus s. No, actually plus s, right? So this is the length of r squared minus 2sr plus the length of s squared. Yeah. And then this actually connects back to this thing. No, doesn't connect to that one. This right here, this connects to this thing. It connects back to this. So we just use the method of elimination. So I cross this out. And then after we cross that out, we cross this out. Right? And so basically, if we move this here, if we move, if we move this there, so like, no, wait, how to explain this? Alright, so this is this, right? And since we crossed out these from these, then basically this eliminates this and this eliminates this, and that means this is this, right? Right? And so, therefore, that means let's make like a little square over here. Therefore, that means minus 2SR equals, what did we had? Minus 2 times by the length of R times by the length of S and cos sin, right? Angle. And so we get, we cross the minus 2 way, and we get R times S, or S times R, whatever it is, equals the length of R multiplied by the length of S. Right? Is it correct? Is this how you do it? I forgot. Kayak gini kaya? Was it like this? Yeah, I got it right. Yay! I got it right. So this is the cosinus dot product formula. Yeah. Jadi ini adalah formula atau rumus untuk cosin dot product. Yatta ze! Yatta ze! Okay, so let's actually put in some real equations now. So what was it again? It was, the formula was S times R equals the length of R times the length of S times the angle, right? The cos angle, the cosin. So let's say, mari kita bilang, we have this. Let's say we have this angle. So let's say that this thing is S, and let's say that this thing is R, and let's say that let's say that the angle here is 90 degrees. So basically, because the equation is because the formula is R times S equals the length of R times by the length of S and the angle, the cosin. We gotta determine the cosin, so the cos for 90 is going to be 0, right? So if you even if you multiply the length of R and the length of S, and the dot product is 0. Right? Is this right? Or let's get another line. Let's say we have the line of R right here. And we also have a line of S right above R. And because there is no angle at all, basically, the angle is non-existent and it's 0, right? So, if we count this in, that means it's R times S equals the length of r times by the length of s multiplied by the cos of 0. And the cos of 0, wait, that's a 9. And the cos of 0 is 1. So this is yeah. Yeah. So yeah. Or let's say we have this vector. This is the r vector and this is the s vector. And that means the whole angle is a whole 180. That means this is a cos 180, which is minus 1. That means r times s equals minus the length of r times by s. Yeah. Yeah. I think this makes sense. Yeah. I'm sorry guys, but as confused as you guys are, I'm also very confused. I'm learning together with you guys. The title is We'll Study Algebra, and I'll make sure of that. I'm not teaching you guys anything. We're just studying together. Hehehe. So now let's learn about projections. Sekarang mari kita belajar tentang proyeksi kali ya. Projections. So remember there's that one guy that said that the cosin was the adjacent divided by the hypotenuse. Yeah, basically adjacent divided by the length. Let's put length of A here. Right? So, what happened to the music? Oh, there we go. I thought the music disappeared. So, let's meet up with Mr. R again. We have Mr. R over here. And then let's meet up with Mr. S. Mr. S is over here. Oh, no. Okay. So let's say we have Mr. R, then we have Mr. S right over here. If we pull this down, then that means we can have a nice 90 degrees, also having a theta over here. So if you try to multiply S and R, then that's basically with the formula that we just discovered. And that means this is the length of R times by the length of S times by cos theta. And this is the adjacent. So basically, the cosin is the length of S cos theta divided by the length of R. Yeah, and if the theta, if this angle is like 0 degrees, no, not 0 degrees, 90 degrees, then that means There's no projection. Yeah, you see, this thing right here. I remember. This thing right here. This is called the projection. The S right here. It's projecting stuff. It's projecting a shadow. Or a light. Whatever you like. Right? This is the projection, and the projection is the adjacent. So, if we want to look for the dot product, basically, because this is the cosine, it's basically R times S divided by the length of R equals the length of S cos theta. Because this is the scalar projection from here. Yes. And if I want to encode which way R is going into the dot product or into the projection product, then all I need to do is I get these two in. I get them in, but we also multiply the length of R with another length of R, so that makes it length of R square. And this will become R times S divided by R times R. And they both will be timed by R2. Because that is the vector projection. Hence, which is why you use simple past tense, no, simple present tense, when you want to state a repeated action, facts or generalization, scheduled events in the near future, or tell what's happening right now but in a non-continuous verb. Basically, it's subject plus verb plus object. And if this is he, she, it, then we add an S behind the verb. If we want to use non-continuous verbs, then we use two B's. And remember, he, she, it uses the to be is, while the other I, you, we, they, we use a variety of am and are. Also, we use has for he, she, it, and have for I, you, we, they. There will be adverb placements, and that will further explain when it takes place or what's happening. It'll give details on what comes next. Thank you. I thought this is a math stream. Why, Siska, hello! Would you care to learn simple present tense with me? For example, a little example of what a simple present tense. I study math. Notice how I instantly meets up with verb 1 and doesn't have any other suffix at the end. And we do not use two B's in the middle of It is not I am study math. It is not I is study math. It is I study math. We do not need the two B's in it. And if you're trying to point out at someone else, for example, let's say that we want to take the subject of he, then we just put S at the end of study. He studies math. And you know, if we want to make it negative, all we need to do is just put don't. And between the subject and verb 1. Same goes to he, she, it, but he, she, it is a very, very special case. Because when they turn into the negative, then we don't put he don't study. No, this is incorrect. We put he doesn't. Because that's just the law of English. And when we already have the he doesn't, then we don't need to put another S at behind of study. It's not he doesn't studies. No, it's he doesn't study. Yes! If you want to turn it into an interrogative sentence, then all you need to do is switch them around. Remember how we put the 2B of don't in the middle of a subject and verb 1? All we need to do if it turns into an interrogative is that we put it at the front. For example, do. We put it at the very front, then we put a subject right over here, you. And then we put the verb study. And also the object. Math. As simple as that. We use this also to state repeated actions. For example, for a good example, Siska will be our main subject. Okay, and Siska, mind you, Siska is not an I, Siska is not a you, because we don't know if you're really Siska. We're not talking directly to Siska. Siska is an individual, is not plural. It does not mean that Siska is us. It is not we. Siska does not belong in this category. Siska belongs in the category of he, she, it. Siska breathes. Because this is a repeated action. And because Siska falls into the category of he, she, it, we put an S at the end of it. Breathes. And then we put the object. The object being air. Super, thank you. I'm okay. I'm okay. Japanese class when. You guys need to know the differences of when to use no, when to use to, when to use de, when to use ni. These are basic. Oh, also wa and ga. These are basic Japanese particles. You use no when you want to point out to possessive. It's a possessive particle. To is basically when you want to. It's a particle that you put right after something that's with you. A day is a place along with ni. I don't know the differences between them. Wa and ga is pretty similar too. But wa is more to is. And sometimes you use it for negatives. You use it for, I don't know. There's still a debate to how we use ha, wa, and ga. Also, did you guys know that sugar and protein, they are processed differently within our bodies? Do you guys ever wonder why bodybuilders go on a protein diet and not a sugar diet? Have you guys ever thought of that? Well, that's because sugar goes through 3 cycles. 3 cycles of digestion. While proteins only go through 2 cycles. Hence, it's a lot easier for our body to actually digest protein rather than sugar. Okay? Do you understand? We're studying math, mind you. Yes! Are you okay? I am definitely okay. What else? You want me to teach you linear algebra? I'll teach you linear algebra. Do you guys know Pablo Picasso's full name? Pablo Picasso's full name is Pablo Diego Jose Francisco Pablo Diego Jose Francisco de Paula Juan and Nepo Mucheno. Pablo Diego Jose Francisco de Paula Juan Nepo Mucheno Maria de los Remedios Cipriano de la Santísima Trinidad Ruiz with a Z like Picasso. Thank you. So that has been linear algebra. Yeah. You good now, Holly? Oh, I'm good. I'm good. Where's Lopez? There's no Lopez in Pablo Picasso's name. Wait, let me try to memorize that. Right? This is correct, right? I didn't get anything wrong, right? Thank you. Pablo Diego Jose Francisco de Paula Juan Nepo Muceno Maria de los Remedios Cipriano de la Santísima Trinidad Ruiz Picasso. Hi, というわけで来てくれて本当にありがとうございました。Thank you so much everyone for coming to this stream. Terima kasih banyak telah datang ke streamnya Oli. Berikutnya Oli akan membacakan donasi. Next up I'll be reading donations. So thank you so much everyone. Let's go.